Welcome to the module 2 contents, that is the robotic kinematics and the control system. So here we are going to discuss with respect to 3 degree of freedom in two-dimensional cases in case of the robotic system. The forward and inverse kinematics of a manipulator with 3 degree of freedom in the 2D environment you are supposed to consider. So here the parameters in the 3 degree manipulator, here there are 3 link lengths and the 3 orientations you are supposed to measure. The end effector position is xy, it is the position in the plane, and the orientation angle of the end effector, it will be pi. So in the forward kinematics, xy, it is calculated by the equation L1 cos theta 1 plus L2 cos theta 1 plus cos theta 2, L3 cos of theta 1 plus theta 2 plus theta 3 it comes. If it is y, L1 of sin theta 1, L2 plus L2 into sin theta 1 plus theta 2 plus L3 into sin theta 1 plus theta 2 plus theta 3 it comes. So overall orientation equation phi is equal to theta 1 plus theta 2 plus theta 3. So like this you'll be able to calculate xy coordinate and the orientation. In case of forward kinematics, if it is inverse kinematics, then the desired position xy and the desired orientation is supposed to calculate. So here in the inverse kinematics for the 3 degree of freedom, this position xw yw is equal to x minus of L3 cos phi, y minus of L3 of sin phi. Will be able to use the equation to compute. To find out the theta 2, cos inverse of xw square plus of yw square minus of L1 square minus of L2 square, whole thing divided by 2L1 into L2. By this we'll be able to calculate the orientation. For theta 3 it is equal to phi minus of theta 1 plus of theta 2, we'll be able to calculate. So what are the characteristics of 3 degree of freedom planar manipulator? Provides position and orientation control in a plane, have multiple solutions for the manipulator to work out. It is more flexible compared to 2 degree of freedom manipulator. The applications of 3 degree of freedom forward and inverse kinematics is assembly robots we can apply, pick and place manipulators inside the robot we can extend, painting operations in the robot we can do, industrial automation system where all things will be automated at the workplace for better efficiency of the robot. After 4 degree of freedom, after 3 degree of freedom, coming to 4 degree of freedom in 3-dimensional system is 4 degree of freedom manipulator. Here I got 4 lengths and 4 orientations. So in the forward kinematics, you are going to get position equation xyz and the orientation phi. So x is equal to L2 cos theta 2 plus L3 of cos theta 2 plus cos theta 3 plus L4 of cos theta 2 plus cos theta 3 plus cos theta 4 into cos theta 1. Y is equal to L2 into cos theta 2 plus L3 of cos theta 2 plus cos theta 3 plus L4 of cos theta 2 plus cos theta 3 plus cos theta 4, overall multiplied by sin theta 1. Z is equal to L1 plus L2 into sin theta 2 plus L3 into sin theta 2 plus sin theta 3 plus L3 into sin theta 2 plus sin theta 3 plus sin theta 4. You are supposed to take. Phi orientation can be calculated by theta 2 plus theta 3 plus theta 4, which you can combine. So by using this parameter, you will be able to do 4 degree of freedom manipulator. So if it is inverse kinematics, here theta 1 is calculated by tan inverse of y by x. So the desired portion what you have to compute is x by z. So here the calculate the planar distance is r is equal to root of x square plus of y square. Z dash is equal to z minus of L1. So to find out the orientation at theta 3 is cos inverse of r square plus of z dash square minus of L2 square plus minus of L3 square divided by 2 times of L2 into L3. Theta 2 also can be calculated by tan inverse of z dash by r minus of tan inverse of L3 into sin theta 3 divided by L2 plus of L3 of cos theta 3 theta 4 is equal to 5 minus of theta 2 plus theta 3. Like this you'll be able to compute. So what are the features of 4 degree of freedom manipulator is it can work in 3D workspace without any difficulty. Position and partial orientation can be easily controlled. So here 2 degree or 3 degree of freedom manipulator provides more flexibility and reach easily. So what are its applications is industrial assembly robots, welding robots, painting robots, pick and place robots in the manufacturing cell, so that it can be able to use in all the three directions compared to 2D or 3D 3 degree of freedom manipulator. 4 degree of freedom manipulator, it is more flexible compared to the earlier systems of robots.